Welcome, I'm Kevin King. In this, the sixth and final video, we'll be looking at the configuration file editor, what it does and how to use it. Other videos in this series take you all the way from how systems work through to creating configuration files for crop or machine geometries that you've not already got stored preset configurations for. You can select the video you need from our website and view it as many times as you want. The same material is covered in rather more detail in our reference manuals, which can also be downloaded from our website. The Intro reference manual is available in English, French, Spanish, Polish and German languages. So firstly, what are configuration files? They are files that contain all machine and crop parameters that can change between alternative applications. For example, parameters relating to machine geometry or sensor choice, such as camera height or position sensor stroke. Putting these parameters into configuration files rather than hard coding them into the application allows the guidance software to be written in a generic way that offers a great deal of flexibility to machinery designers. So for example, our Intro guidance software can as standard accommodate front and rear mounting, side shift or disc and wheel steering. We can take data from multiple cameras and steer multiple independently guided sections, scaling from very large machines tracking tens of rows in a variety of patterns, to very small implements tracking as little as a single row. We can accommodate a wide range of sensor types, and in many cases take data from alternative sources. All of these can be accommodated just by changes to configuration files. There are therefore a large number of parameters stored in a configuration file, but for a given machine type it is usually only necessary to change a small number of them between applications. Defaults for generic designs have been created so that implement manufacturers only need alter specific items, such as side shift stroke, to customize the default to a specific machine. Configuration files make life simpler. From the user's perspective, all potential complexity is hidden. Users are only required to select from a limited number of preset configurations, tailored to their particular machine and setup. Most machines only require between 1 and 3 configurations. For example, to cover 3 different crop configurations a customer may use their machine on. But if necessary, up to 32 can be accommodated. So when users go to the field, they only have to set the appropriate crop height for the day and to select the correct configuration, and then they are ready to go. So what does the configuration file editor do? While the number of parameters that you need to change is small, we do need a way to make those changes. The configuration file editor is designed to do that job. As well as its function as an editor, it also provides some guidance on how to select values via a help facility. It also checks parameters for compatibility, and warnings are issued or guidance offered if certain criteria are not met. The editor is intended for use by manufacturers and dealers. However, keen, experienced users have been known to successfully edit their own files, and we have no problem with that. In the remaining slides, we will explain how to use the editor, and we will give some examples of how to make commonly required edits. It is possible for Tillett and Hague to supply customized default configurations to reduce the number of parameters requiring modification during factory setup. You can enter the editor from either the home screen or the advanced settings and diagnostic screen by touching on the pen and paper symbol. Having touched the button, you'll be asked to enter a 4-digit PIN code. This is not intended to be high security, but should prevent the casual user from accidentally getting into a position where they can alter important settings, though you should always have a backup file ready just in case. See video 5 on how to take a backup. The default code is 1234. If required, you can reset that code from the service menu. If you change your mind and want to go back, touch on the bottom right home screen button. If you get the code wrong, you'll be returned to the home screen automatically. If you find that you are locked out, contact your dealer for reset instructions. If your code is correct, you will enter the editor. This is the top page of the editor, and will include a list of all the configurations loaded. If you touch on one of the file names, its text will turn white to indicate that it is selected. The buttons on the right allow you to manipulate files. The top right button, with the drawing of a single file and a plus symbol, creates a new file. If touched, you are presented with a series of choices regarding the type of machine you want to create a file for example steering method and implement type. Following these choices will eventually lead to a default configuration that offers a starting point for a new configuration. The newly created file will be added to the list and given the name New1 and selected ready for editing. However, it is very rarely advisable to create a new configuration in this way. It is usually easier and safer to use the copy function by selecting the file you want to copy and touching the next button down with the to folder symbol to create a new file based on the one that is already known to work. That new file is added to the list with the name New1. It is selected and ready for editing. This is the preferred method for creating new files on a working machine. The third button, with a file and pen symbol, starts the editing process on the selected file, presenting a list of configuration file parameters that are available for editing. Touching the fourth button down with a bin symbol deletes the selected file. When deleting a file, you are asked to confirm this in a subsequent window, as files cannot be recovered following deletion. The bottom button, labelled with a loop back arrow, as you would expect, returns you to the start menu. Note that when you next run the system, you need to select the appropriate configuration file, as editing a file does not automatically select it in the main application. In this screen, you will have the opportunity to edit parameters associated to machine sections and cameras. The topmost button of the right of the screen, with a spanner ++ symbol, toggles between advanced and standard modes. The advanced mode offers a choice of more parameters for editing, and is only required to make the less common changes. Wherever possible, stick to standard mode. The button below toggles between metric and imperial units. This changes the units used on all screens. Again, as normal, the loop back arrow takes you back up a level. Having opted to edit a file at the first level, you have the option to edit the name. If you have just created a new file, then you will need to change it from New1 to something that will be more meaningful to the end user. The file name can be up to 8 characters long, and that might be descriptive, such as lettuce, or it can be numeric, such as 3 rows, 50 centimeters, indicating that the configuration is to follow 3 rows of a crop grown with 50 centimeter row spacing. To edit a name or a parameter, touch on it. A cursor will appear next to the text and an alphanumeric keyboard will pop up and you can use it in the normal way. Note the red question mark key. If you touch on that key anywhere in the editor, you will be offered a context-sensitive help message. This can be very helpful, so do use it. A section is a frame that moves using cameras. Most machines only have one section, but if you wish to track multiple independently planted bouts, then you need multiple independently steered sections. This particular machine in the example is fitted with a single section with index number of 0 and 2 cameras with index numbers of 0 and 1. For reasons of computing history and convenience, component index numbers start with a 0. For example, a 2-camera system with the first leftmost camera will have the index number 0 and the second camera index 1. If you touch on the index number on the edit section or edit camera line, you'll be able to edit the associated parameters. If your implement has Isobus connection, an additional setting of speed source will be displayed. This gives you the option between selecting an Isobus derived odometer input or a microcontroller or vision-based odometer input. Pressing on the currently selected speed source will generate a pop-up menu for selection of your chosen odometer source from the inputs available. The currently active selection is displayed brighter than the other available options. Press on your desired speed source to select it. We will now explore what happens when you touch on the Edit section 0 index number. Here we see the section parameters you can edit in the standard mode. The first is width. This is the working width of the machine and is used solely for determining area worked. It has no bearing on guidance performance. Below that, there is a list of the cameras used to guide that section. Again, in this example, there are two fitted, listed here as 0, 1. For a single camera implement, the cameras listed would simply be 0. The bottom line offers the opportunity to edit steering parameters. These are the settings relating to how the section position sensor feedback operates, or proportional valve settings. Typically, these parameters are for advanced users only. You can find more information on these in the manual. Go back to the previous screen with the loop back arrow. We will now explore what happens when you touch on the Edit Camera 0 index number. Now we can edit camera parameters. These should look familiar as they are the parameters you see in the setup screen, and this being where, if necessary, we can change them. For more on how to decide which values these parameters should be given, see video number 4 on setting machines up. Top is the height and is measured from the centre of the camera lens to the ground level. Next are the camera angle and the look ahead, the distance between the centre of the view of the camera back to the point vertically underneath the camera. These are both a measure of camera inclination. You only need to enter one and the other will be automatically calculated. Next is a measure of the distance backwards from a point vertically under the camera to where the treatment device is placed. This figure need only be measured approximately for inter-row guidance. It is used to calculate the offset due to the implement heading angle. Next is the number of rows that the camera is attempting to track. And finally is the spacing between the rows. In this example, we have an even number of rows and the setting of the row spacing is straightforward. There are 4 rows we want to track and the spacing between the rows is clearly 0.4 meters. This example is slightly more complicated. There are 5 rows we want to track, which is fine, but the spacing between the rows is not even. The outer rows are further apart than the inner rows. To express that, we list the different row spacings starting from the central row spacing and working out. Our system assumes symmetry, so it's important that the pattern is the same either side of the camera center line. In this case, working out from the center, the inner row spacing is 0.4 and the outer spacing is 0.5. We put a comma between the numbers to separate them. As before, in a similar situation, 4, an even number of rows. Working from the middle, row spacing would be 0.8, 0.5. We can expand and apply these principles to cover quite complex patterns. In this case of triple rows, typical for crops like carrots. We want to follow 3 triples, so the number of rows is 9. To get the row spacing, we simply start at the centre, with 0.05 meters between the central and first row, and work our way listing each spacing at a time, until we get to the edge of the pattern. Note that as always, the pattern is symmetrical about the centre line. Here is another example using the same principles, with even more rows, 12 in this case. But the principle is the same, working out from the centre. The row spacing list just gets a bit longer. While we do not recommend guidance using a single row, we appreciate in some cases, due to various constraints, guiding only on a single row may be necessary. When setting up for a single row, the value used for row spacing is linked to the foliage width of the tracked row, and not the distance to the adjacent row. We should measure the foliage width of the tracked row, in this case 15 centimeters or 0.15 meters. We should then multiply this value by a factor of 2. This will give us our row spacing value to enter into the configuration file. So for this case, 30 centimeters or 0.3 meters. But be aware, due to the sensitivity on guiding on a single row, the values entered into the configuration file should be no lower than 0.2 meters or higher than 0.5 meters. If you are able to view multiple crop rows for guidance, this will always yield better results compared to a single row. The decision on how many rows we attempt to track will depend on the field of view of the camera. In general, the more rows and the longer the length of row in view, the better. But there will be some practical limitations on camera position and orientation. So it's often the case of positioning the camera to maximise the view when working out how many rows it is possible to track. In this example, we can follow 3 rows. Note that in order to completely track a row, we need at least half a row width or spacing to be in the view to the side of the outer row. In this example, that requirement has been met, and all 3 rows will be tracked from the top of the image to the bottom. You should receive no warnings entering this configuration. Perspective may mean that this condition is met at the top but not at the bottom of the image, and this will trigger a warning. However, it's only a warning. Our software will automatically stop tracking outer rows lower in the image while continuing to track all rows at the top. In this illustration, the track lines are shown as solid green lines and the non-track rows indicated by dashed green lines. The working screen image will show rows as no longer being used for tracking similarly through dashed green lines. So the machine will be tracking on a single row with the support from the outer rows at the top of the image. This is significantly better than following a single row, but if you are able to increase camera height to get a wider field of view without the tractor or implement getting in the way, then that would be better still. In this situation, where you are attempting to follow only 2 rows and they cannot be tracked at the bottom of the image because they are too close to the edge, then this is not acceptable. The best solution is to increase camera height and/or increase look-ahead distance so that you can view a wider area. If that is not possible, you may have to consider following 1 row and fitting a second camera following a second row for added reliability. Whilst not very robust to difficult situations or poor crop emergence or high weed infestation, single row configurations do have the advantage of not being sensitive to template match. Middle is middle for both template and crop row, making calibration less important except for the calculation of things like speed via visual odometry. As mentioned earlier, the standard version of the configuration file editor is all that you need to change standard things such as camera height and row spacing. However, there is an advanced mode that allows you to edit more parameters. You reach that by touching on the Spanner++ button, which toggles between standard and advanced modes. In advanced mode, you will see more headings allowing you to make more changes. These changes include adding a second camera, adjusting odometer scale, changing the source of odometry, changing the source of lift input, selecting optional features, for example enabling alternative colour options, fine offset options, and the speedometer scale adjustment to suit your application. We will go through these in detail, but there are other changes not covered here that can be made following similar procedures. One of the more common requirements for advanced mode is adding a second camera to a single section machine. On the first page, you simply have to change the number of cameras from 1 to 2. A pop-up prompt box will then ask you if you want to assign the new camera to that section. If you answer yes, the camera will be used for guidance in the usual way alongside the original camera. If you answer no, the camera will still appear on the working screen, but it will not be used for guidance and will therefore have no blue crosses. It is effectively now a CCTV camera that you can mount in any way that gets the best possible view of what you are trying to monitor, normally the relationship between the blades and the crop rows. When adding an additional camera, settings are automatically copied from camera 0, as it is quite typical for cameras to be set up identically. However, there are circumstances where there may be an advantage to setting 2 cameras differently, to deal with a wider range of crop growth stages, for example. Camera parameters can be edited for each camera in the usual way. Staying on the first page, let's look at odometer scale. For newer versions of software, this value can be accessed via the standard configuration editor, but for older software versions, it is part of the advanced configuration editor. It is the distance travelled between pulses from your distance measuring device. It has the units of meters per bit or inches per bit when in imperial. If you are connected to the tractor's 7-pin ISO 11786 socket, the odometer scale should be set to 0.00769 meters per bit. If you are set up to use visual odometry, you do not need to set this number as it is dealt with internally and will ignore any number given here. If you are using an odometer wheel to generate odometer signals, then the scale is calculated by dividing the circumference of the wheel by the number of pulses per revolution. In this example, for a 0.3 meter diameter wheel fitted with 13 studs, the scale would be 0.0723 meters per bit. In order for odometer scale to be displayed, the speed source should be set to odometer/vision. In the case of an isobus input, this is pre-calibrated, so does not necessitate an odometer scale. Having set the odometer scale, we now need to specify where the odometric data is coming from, in the case of wired or visual-based odometer inputs. Selecting a section index number on the line Edit Section allows us to edit parameters relating to that section. This is simple for single section machines as there's only one section, section 0, so you should just touch on the 0. On this page, we will specify the source of odometric data. If a section has odometric input from an external source, ground wheel, ISO 11786 socket, or GPS speed sensor, you need to specify which microcontroller it is connected to. Our Intro systems almost always have just one microcontroller per section, so microcontroller and section always have the same index number starting with 0. So on the odometer on microcontroller line, specify the same index as the section number, in this case 0. If it were section 1 of a multi-section implement, you could also enter 1. Note on the screen the word microcontroller is abbreviated to μC. If there is no odometric external speed input to a section, leave that line blank and the editor will automatically insert the text None. Multi-section machines may get odometry data from just one or multiple sections. It is quite common for multi-section machines using odometer wheels to fit one wheel on each section to improve reliability and to allow work to continue if one section is lifted. If a machine has no odometric input at all on any section, the system will default to visual odometry. Therefore, visual odometry is achieved by setting odometer on UC to none on all sections. In that case, any odometer scales entered in the previous page will be ignored. If your implement has isobus connection, lift input can be potentially sourced from several different places. This gives you the option between selecting an isobus-derived lift input or a microcontroller lift input. Pressing on the currently selected lift input source will generate a pop-up menu for selection of your chosen lift input from the available sources. The currently active selection is displayed brighter than the other available options. Press on your desired lift input source to select it. Go back to the Configuration File Editor top page. This time select Optional Features. To reduce complexity, we recommend not enabling any more colour choices than are essential for good performance. It is important to realise that there is much more scope for reducing performance by moving away from the standard green than there is for improving it. Having said that, there are some situations for which an alternative colour setting is either essential or highly beneficial to performance. The first line allows users to select some crop colour choices other than the standard green via the working screen. The default colour choices are between green, the standard setting, red for red leaf crops, and RNG for crops with a mixture of red and green leaves. These are very useful for specialty salad growers. If you answer yes to offer crop colour choice, additional options will be given. As a refinement, that choice can be offered per camera. This is rarely a good idea and generally you should set all cameras the same with respect to colour choice. If the standard colour options are insufficient, you can opt to have customised colour choice. If you do opt for custom colour, there are two ways that can be implemented. The first is to enter a fixed custom colour value that users can select from the working screen as an additional colour choice. This might be appropriate for an onion or leek grower whose crops at some stages may have a blue hue to them. In that case, a value of about 20 to 30 might be appropriate. If users can see that their crop is visibly blue, then they can try that option. The second custom colour implementation allows users full freedom in selecting custom colour. If you answer yes to this, a graphical tool is enabled allowing colour to be varied from the working screen. This should only really be enabled for highly experienced users who grow non-green crops, as correctly setting custom colour requires considerable skill. It may be worth considering the use of a near-infrared camera as an alternative camera type for use in crops that would traditionally require frequent use of custom colour adjustment to operate. This alternative camera type is auto-recognised by the system and avoids the need for skillful fine adjustment of custom colour. There are 3 operator-related options available from the Optional Features section of the Advanced Configuration Editor. The number of fine offset steps available from the working screen can be adjusted here. Typically, this is set to 6 steps of offset to the left and 6 steps of offset to the right. It is sometimes advantageous to have more than this amount, in particular for use in severe side slopes, where 6 steps of offset is not adequate. 10 steps is often sufficient in these cases. The size of the fine offset steps is also configurable from the default of 1 cm per step of fine offset. This should only be adjusted for ultra-precise applications such as baby leaf salads. The speedometer scale can also be adjusted to cater for the expected operation speeds of the implement, as 0 to 20 km/h scale may not be suitable for all applications. Entering a value into here will set the top of the scale. We hope that you have found this presentation useful. Remember, this is the 6th and final of a series of presentations covering our Intro Vision guidance systems, that you can select from our website and view them as many times as you want. Our website also has links to other reference and training material, including full reference manuals in a variety of languages. If you have any questions, please get in touch. Thanks for watching and good luck.